Hey guys, so I'm going to explain to you how to find turning points, maximums, and minimums. So the points at which a polynomial function switches direction, they're called turning points. So this would be a turning point as well as this being a turning point. So if the turning point is higher than any nearby point, it's called, that would be this one, it's called a relative maximum. Because relative to what's around it, it's the highest point. If the turning point is lower than any nearby point, it's called a relative minimum. Okay? Maximum and minimum values are called extrema. They're extreme values on the graph. Turning points define where the function is increasing or decreasing. So as you can see from this function, it's increasing up to this turning point, then it decreases down to this turning point, and then it increases again. Okay. So we're going to find the turning points of this function here. So you're going to pull up your calculator, and in your calculator, you're going to punch in that function, x cubed, x rooftop 3, minus 6x squared, plus 7x. Oop. Gotta go back and fix that. Plus 2. Okay, then you're going to graph that. You may have to hit zoom 6 if your graph is over. You're going to use the calc menu to find the minimum and maximum values, and we've done this before. So the first one we're going to find is this one up here, so that's a maximum. So I'm going to do second trace, which is calc, go to maximum, which is number 4. Okay, my left bound would be on the left side of the top, and I hit enter. My right bound, I would move my cursor over to the right side of the top and hit enter, and then guess I hit enter again. And I can see there that it says my maximum point there would be, it would be 0.709, comma 4.303. Okay, so that would be a relative maximum. Now a relative minimum, that would be this point down here. So again, I hit second trace, number 3 for minimum. Okay, and my left bound's on the left side. I hit enter. My right bound's on the right side. I hit enter. Then I hit enter for guess. Okay, and I see that my minimum there is 3.291, comma negative 4.303. Okay, so the next thing it says is increasing intervals and then decreasing intervals. So with my increasing intervals, it's going to be going from the left side over here. Remember, when I'm doing intervals, I'm talking about x values, not the y values, the x values. So if I go from here, my function is actually increasing until it hits this x value. And we found that from finding our relative maximum. So when it hits that value, it's no longer increasing. So my first interval would actually start at negative infinity for x, and it would go to the 0.709. Okay, remember, you do a bracket around your number, a parenthesis around your infinity symbol. Okay, then starting at 0.709 until I reach my minimum, the graph is decreasing. So my decreasing interval would be from 0.709 for x up to 3.291 for x. Okay, and then as you can see, the graph goes up, so it's increasing again. So it starts increasing at 3.291, and it never stops increasing. So that would be to positive infinity. Okay, you notice that each interval picks up where the last one left off. Okay, that's all on this video. I'm going to do the next example on a separate video.